The function f of x equals 10x minus 2 is 1 to 1. Find the inverse of f, check the answer, find the domain and range of f and f inverse, and graph f and f inverse and y equals x on the same coordinate axis. So first we'll start by finding the inverse of f of x equals 10x minus 2. Start by changing f of x to y. Then you'll switch the x and the y. This step is essential to finding the inverse because inverses switch x and y coordinates. Then we're going to solve for y by adding 2 to both sides and dividing by 10. We get y equals x plus 2 over 10, and that's going to be f inverse. F inverse of x is x plus 2 over 10. Then we want to check. So to check that these are inverses of each other, we're going to do f composed with f inverse and f inverse composed with f. If these two functions are actually inverses of each other, when we work this out, we should get x. Inverses are going to have inverse operations or opposite operations, and those opposite operations will cancel each other out, leaving us with just an x. So we'll start by calculating f composed with f inverse. This is substituting f inverse inside of f. So we're substituting the inverse in for x. That would give me 10 times x plus 2 over 10 minus 2. And we're simplifying, the 10's cancel, leaving me with x plus 2 minus 2. Plus 2 minus 2 cancel to become 0, leaving me with x. So that's good. We need to calculate f inverse composed with f. This is substituting f in for f inverse. So we're taking f and substituting it into the x in f inverse. That would give me 10x minus 2 plus 2 over 10. And when we simplify, minus 2 plus 2 becomes 0. That leaves me with 10x over 10. 10 over 10 is 1, and that leaves me with x. So we found the inverse, and we also checked to make sure we had the inverse. Then let's find the domain and range. So starting with f of x is 10x minus 2. This is a linear function or a polynomial function, so it has a domain of all real numbers. And because we switch the x and the y, this will be the domain or the x's for f, but it'll become the range or the y's for f inverse. So the range of the inverse will be all real numbers because the domain of f was all real numbers. If we look at f inverse, that's x plus 2 over 10. This is also a linear function. You could write this in slope-intercept form. That's 1/10 x plus 1/5. So because it's a linear function, the domain of f inverse is all real numbers. And the range of f is all real numbers because the x and y get switched. Finally, we want to graph our function f and our inverse and the line y equals x. So we want to graph f of x equals 10x minus 2, f inverse, which is 1/10 x plus 1/5, and also the line y equals x, all on the same coordinate picture. So f of x is a linear function, and it has a y-intercept at -2 and a slope of 10. I'm going to rise 10 and run 1. So I get this line here. And then we want to graph the line 1/10 x plus 1/5. So we're going to have our y-intercept at a fifth, which is about right here. We want to rise 1 and run 10. That would put me about right here. I'm estimating a little bit because of the fractions. And then we want to graph the line y equals x. So the line y equals x is this line right here. And hopefully what you're seeing is that f and f inverse are symmetric around this line y equals x. You have a mirror image if we fold over that line. Match the graph to one of the following functions. So we have our graph here, and our functions y equals 5 to the x, -5 to the x, 5 to the x minus 1, 5 to the 1 minus x, 5 to the negative x, -5 to the negative x, 5 to the x minus 1, and 1 minus 5 to the x. These are all exponential functions, all transformations of the same base function, 5 to the x. So I want to start by just getting a sense of what the base function looks like of 5 to the x. I can do that by making a chart. I'm going to substitute in -1, 0, and 1. So 5 to the first power would be 5. 5 to the 0 power would be 1. And 5 to the -1 power, that's where the negative has you take the reciprocal of the base. So that's the 1/5 power. So if we sketch out what the graph looks like, we have the point 1, 5, 0, 1, and -1 and a fifth. So this is a sketch of the graph. And these exponential functions will have a horizontal asymptote at the line y equals 0. So you can see that this is not the correct answer choice when you compare it to the graph we're trying to match here. So this one is out. Taking a look at the next one, y equals -5 to the x. This -5, this negative here, is a vertical reflection. Let me just label this. This picture is y equals 5 to the x. We're going to start with this picture every time we draw one of these graphs. So for answer choice C, y equals -5 to the x. That negative vertically reflects the graph, which would make it look like this. You can see that that's clearly not the right answer choice. Then looking at answer choice E, y equals 5 to the x minus 1, that minus 1 is a vertical shift. So once again, starting with this picture, if we were to vertically shift down 1 unit, that would take the vertical asymptote down, the horizontal asymptote down, giving us a picture that looks like this. So that's not the right answer. The next option, G, y equals 5 to the 1 minus x. I'm going to do a little bit of rewriting so I can understand exactly what transformations are going on. So I would write the negative x plus 1 and then factor out the negative to get negative times x minus 1. And now with it written this way, I can see that this minus 1 shifts the graph to the right 1, and this negative reflects horizontally. So this is going to give us a graph. So if we move to the right 1, so once again starting with this picture, I'm going to move to the right 1 and also reflect. We get a picture that looks something like this, and that is lining up to match our picture here. So I'm going to hold on to G and just verify that the rest of these are not right. So if I look at answer choice B, it's y equals 5 to the negative x, and that negative is a horizontal reflection. So the graph would reflect horizontally like this. When it reflects horizontally, this point right here, 0, 1, is still 0, 1 on this picture, and you can see 0, 1 is not on the picture we're trying to match. So B is not one of the choices. And then for D, that's y equals -5 to the negative x. So this negative will reflect vertically, and this negative will reflect horizontally. So that would give us a picture like this. If we reflect both vertically and horizontally. So that's not the right picture. Answer choice F, y equals 5 to the x minus 1. That would shift to the right. And that's not the right answer choice. Let's see this last one here. Answer choice H. So 1 minus 5 to the x. Y equals that. I'm going to rewrite as -5 to the x plus 1. So this negative reflects it vertically, and this 1 shifts it up. So if we shift up 1 and also reflect, our asymptote is up 1, we would get something like this. And that doesn't match our picture. So that brings us back to the only one that came close, which is this one right here. And just to check one more time, I'm going to check this point on the graph. That's the point 0, 1, 2, 3, 4, 5. If I plug a 0 into this function, so y equals 5 to the 1 minus 0. That's 5 to the 1, which is 5. So at least that 1 point matches exactly. So G is our answer. Solve the equation 5 to the negative x equals 125. I'm going to solve this equation with the one-to-one property, the exponential functions. And that this one-to-one property says that if you have the scenario with b to the u equals b to the v, so you have these exponential expressions with the same base, the one-to-one property says that those exponents have to be equal to each other. Now it goes back to the definition of one-to-one, where if the x's are different, the y's are different. In this case, the y's, this being a y and this being a y, the y's are the same, so that must mean that the x's are the same. So what I want to do is I want to write this equation to have the same base on both sides so that I'm able to use that one-to-one property. On the left, I already have a base of 5. I want to change 125 to a base 5. That's going to be 5 to the third power. I'm going to leave the left the same. And now I have the same base on both sides. Using that one-to-one property, the exponents must be equal to each other. And now I'm able to solve for x by dividing by -1 on both sides. So we get our solution of x equals -3. Which function matches the graph? And they've given me a bunch of log functions with base 3 and all transformations of those log functions. So I'm going to take a moment to graph this basic one here that doesn't have any transformations, and then from that base graph I'll be able to graph all these other ones and see which one matches. So to graph y equals log base 3 of x, I'm going to first rewrite this as an exponential. As an exponential, it would be 3 to the y equals x. Now the reason I do that is because it's much easier to find ordered pairs when it's in exponential form. I'm just going to substitute a -1, 0, and 1 in for y, and we're going to get that 3 to the first is 3, 3 to the 0 is 1, 3 to the -1 is 1/3. So this is going to give me some points to plot. 1, 0, 3, 1, and then 1/3 -1 would be about right here. This log function has a vertical asymptote at x equals 0. And the domain of logs only go from 0 to infinity. So you're going to see the graph of this function is only on the positive side of that y-axis. So that's what our log base 3 function looks like, and you can see that that doesn't match the graph we're trying to match here. But maybe one of these transformations will. So looking at answer choice A, answer choice A will just shift, that -1 shifts the graph right 1. So instead of the vertical asymptote being at 0, it's now at 1. But the basic shape will be the same, so you can see that that doesn't match this one. Then we have answer choice C. That's y equals negative log base 3 of -x. So this negative on the outside reflects it vertically. This negative on the inside reflects it horizontally. So starting with this graph right here, we're starting with our base graph. If I reflect it horizontally, it would go like this, but then I also need to reflect it vertically, so it's going to go like this. And that doesn't match, so that's not our answer. The equation in E is y equals 1 minus log base 3 of x. Let me rewrite that as negative log base 3 of x plus 1. So this negative reflects it vertically, and this plus 1 shifts it up 1 unit. So if I reflect vertically and then shift up 1 unit, it would look something like this. And that's pretty close, so let's keep that one in mind. Alright, let's look at G. So y equals log base 3 of 1 minus x. I'm going to do some rearranging. So log base 3, negative x plus 1, and that's log base 3 negative times x minus 1. So that minus 1 shifts to the right, the negative reflects it. So if I shift to the right and reflect horizontally, remember I'm starting with this graph right here, so reflecting horizontally and shifting to the right, my asymptote would shift to the right, and I would get a picture that looks like this. That does not match. Oh, we said that's maybe, and this doesn't work. Okay, let's see. Answer choice B is y equals log base 3 of negative x. That negative reflects horizontally. So reflecting horizontally would look like this, and that does not match. Answer choice F is y equals log base 3 of x minus 1. That's a shift down. Shift down would look like this, and that doesn't match. And answer choice H, y equals negative log base 3 of x. That negative reflects vertically. So reflecting vertically would make the graph look like this. And that's close as well. So let's see. So if I look closer at this picture, I can see that this point right here is a 1, 0. And that point would only be on this one right here. If you look at the graph, the first graph that we drew, that had 1, 0 on it. So if we shifted that to the right, it would move that point to 2, 0. So this one right here is out, and this is the one that matches. Find the domain of the function g of x equals natural log of x minus 5. So what we know about logs is that you can only take the log of a positive value. So the expression that you substitute inside the log has to be positive. So I'm going to take what's inside the log, set that greater than 0 and solve. So I'll add 5 to both sides. That's x is greater than 5. And my domain will be from 5 to infinity. Or in set builder notation, you can say x such that x is greater than 5.